So in this particular section, we are going to talk about the Laplace transform. So we begin by considering a function f of t. Now we're going to choose the function f of t in such a way that it exists for all values of t greater than or equals to 0. Then the Laplace transform of this particular function f of t is given by the improper integral 0 to infinity of e raised to the power of negative t times f of t dt. Here s is a parameter, so s is a parameter. This parameter is chosen in such a way that s is always taken to be greater than 0, because we know that if we look at the graph of the function e raised to the power of negative st, so this is a decaying exponential. So when we look at the graph of e raised to the power of negative st, we see that when t approaches a very large number, then e raised to the power of st approaches 0. So this has been considered so that the given improper integral converges. So that means it has to be less than infinity, and that means we have a finite value available. So let us try to use this particular definition to find the Laplace transform of a function which is a constant function 1. So let's say we have the function f of t equals to 1. So as already mentioned, that this particular is a constant function and it exists for all values of t greater than 0. So we're only concerned about the function for values of t greater than 0. That means to the right side of the origin. Now the Laplace transform of 1 is simply equals to 0 to infinity e raised to the power of negative st times 1 times dt. Now this is an improper integral because the limits are from 0 to infinity. So in order to solve this particular integral, we are going to use the definition of limits. So we have limit t approaching an infinitely large number. So we have 0 to t e raised to the power of negative st dt. So solving for the integral, so we have limit t going to infinity. So e raised to the power of negative st is going to give us e raised to the power of negative st divided by negative s, with the limits going from 0 to t. So we have limit t going to infinity. So we substitute the value of the limits. So we have e raised to the power of negative st divided by negative s minus e raised to the power of negative s times 0. So that will be simply 0 divided by negative s. So we have limit t approaching infinity e raised to the power of negative st divided by negative s plus 1 over s. Now we're going to apply the limits. So limit t approaching an infinitely large number for the function e raised to the power of st over negative s plus limiting value of 1 over s is simply going to be 1 over s. Now, as already mentioned, e raised to the power of st is a decaying function, decaying exponential function. So for a very large value of t, so that when t approaches an extremely large value or is very far away from the origin, and we know that the decaying exponential is also going to approach 0. So that means the entire limiting value of e raised to the power of st over negative s is going to be equals to 0. So that gives us 1 over s. So that means the Laplace transform of the constant function 1 is equals to 1 over s.